mean by completing the square? So we're going to do our next solving method. You might still get imaginaries. They're not going to go away. Okay? But they might be embedded inside of our process from here. Up until this point, when we're solving, we've had a couple of options. Our first option was to factor. And you still traditionally want to look for that first when everything's all mixed up. Factoring, you can have a GCF, we can have an AC, and then we can also do the difference of squares. For this particular section, they won't be giving you the cubes. So you'll only be really dealing with the squares from now for a while. The second method that we covered was the square root method. And we said that that was a method for if I couldn't do the factoring, right? It might be easier to do the square root. How do you know when you're allowed to do the square root? Not necessarily, because you create the square root, right? There's no what? Yeah, there's no bx in the middle, right? In other words, all you have is just an x squared. You don't have that other x. If you do, you can't do square root method. So then the question today becomes, okay, well, what happens if it doesn't factor, and what happens if I can't square root it? It's not built that way. So now we have another option. So option number 3. We're going to have 4 total, so the 4th one will cover Thursday, and then that's the completion of all of the different ways you can do it. But the 3rd one is to complete the square. That's what it's called. Completing the square is done on an ax squared plus bx plus c when your AC method fails. In other words, you try to do AC method, but it doesn't work. What I want you to connect with is completing the square and AC. I want you to connect that together, because if you can connect it with AC method, then you can recognize when it's appropriate to do completing the square. So if you can't do AC method, if it's not set up for AC, it's not set up for completing the square either. In completing the square, your goal is to create a problem that factors into a square. That's like what we did on our warm-ups, except our warm-ups, we went backwards. We started with the factored form, we distributed it to show that it came to the square. So on this one, you're trying to go the other way. You're trying to create some sort of problem that if I factored it, I would get that perfect square. I would get those 2 parentheses that were the exact same thing. That's the goal of this. If you do that, then we can solve by the square root method. In other words, the point of completing the square is, well, it's not set up like square root method, but if I do a little bit of manipulation, then I can go ahead and do the square root method on it. So our notes are going to be split into 2 different parts. The first part is the setup, and then the second part will be solving. That's the difference between Tuesday and Wednesday assignment. Tuesday is the setup. Wednesday, then you take that setup and you solve. Can I erase? So we'll label this the setup, because that's sort of the first part of completing the square. So what I want you to recognize again, if we just write out what we had on our warm-up. So we had the 2x plus 3 times 2x plus 3 when we distributed that, we said we had 4x squared plus 6x plus 6x plus 9. That's what we got when we distributed. And what we noticed was if these two parentheses are the same, then you got the same middle. In other words, you got twice it. And then we also noticed that you had squares at the end. That's sort of what we were recognizing about that process on the warm-up. In fact, that's always going to happen. So you have a formula that sort of describes this. And that formula says if you have two numbers in a parenthesis, but you square that parenthesis and you FOIL it out, then you're going to have the squares on either end, and then you have plus twice the product in the middle. Now, if you notice, the difference between number 1 and number 2 on the warm-up was one had a plus and one had a minus when we distributed. And the only difference was instead of having two positives, we had two negatives here. So the only difference in the formula, you still get the squares, but that number in the middle will come out to be a negative number because you had a negative in the parentheses. So when we're doing the setup, we have sort of a mini goal. And the goal of the setup is to find the end, which is this guy right here. That's what we're trying to find. So it factors to the perfect square. When you're doing the setup, it's always the same 3 steps. So what I'm going to do is we'll list out the steps, and then we'll go and do a couple of problems associated with it. Can I erase? All right, so steps. And remember, these are the steps just for this setup part, this complete the square part. This is dealing with ax squared plus bx plus c. I want you to notice that this a and this b is not the same thing as that formula that we had up above. It's not the same a, same b. They're referring to two different things. So our steps for this, our first step is that a has to be equal to 1. If it's not, then you have to fix it. In other words, you would have to divide everything by a in order to make a equal 1. Once your a value is equal to 1, since I erased it, let me rewrite it up here. Our formula, we're forcing a to be 1, which means this number here is a 1, which means that the middle is twice b. Does that make sense? I don't want twice b, I want b. So your second step is always to half your b value, which is this value here. So whatever number we see here, we're going to half it so that I can figure out what my value should be. Okay? Well, what goes on the end is not that value, it's that value squared. So my last step is to go ahead and square the result. That number that we get becomes our C value from our formula there. All right, so we'll have 2 examples. Example number 1. They're going to ask you to find C so that the factor is a perfect square. And our problem is going to be x squared plus 10x plus c. So we don't have that back there. So as I'm solving this, I want to figure out what number do I need to put here so that if I factored it, it would come out with the same two parentheses. Now you might be able to do this one in your head. I want you to still to go through the 3 steps because the next one you probably will not be able to do in your head. So step number 1, is a equal to 1? Yes. So I can move on to step 2. Again, if that was a no, we'd have to divide everything by a in order to create it to be 1. All right, step 2. What is my b value? No, I mean like the ABC here. What's my b value? So I need to half that 10. Half of 10 is 5. Now I need to take that result and square it. What do I get? This is your answer for tonight. That's all you would have to do. But let's take this one step further because that's going to help you with the solving. What you found is that number in the back has to be 25. Because if I ran AC method, what multiplies to make 25, but if I add, I get 10. 5 and 5, right? So you would end up with x plus 5 squared. Like I said, all you have to answer today is the 25, but you need to connect that to what you were actually doing. Do you have a question?
I said, could we use the b over 2 squared formula for?
That's exactly what we did here.
Okay, but, okay.
Okay? All right. Example number 2. All right, example number 2 says x squared plus 7x plus c. So again, we're still going to find our c value. Does a equal 1? Yes. So even if you're using your formula, you still have to check that. Okay. All right, step number 2, we're going to half our b. So what's b?
3.5.
7. So if I half that, leave it 7 over 2. It's going to make your life easier, especially when you're solving, if you leave these improper and leave them fractions. Okay? Otherwise, it gets a little chaotic as you solve. All right, step 3, we're going to square that. So what do I get when I square that fraction?
4.
Good. This is the first benefit to keeping that a fraction because you can just square the top, square the bottom. If you have the decimal there, it becomes a little bit of a mess. Okay? Questions with that? Yes?
So it would be just x squared plus 7x plus
49 over 4. All right. So let's go ahead. That kind of, like I said, that's all you're going to do for the first part. And then the part that you'll work on tomorrow is the solving. So let's go ahead and jump into that step. So that's our second sort of big topic on this section. We do have steps for solving. So once again, we'll do our steps here and then we'll do our example after that. Step number 1 typically is that you are going to end up getting rid of the original C value that's there. And normally you get rid of it because it won't factor. So we'll talk about that in a minute. Step number 2, you're going to go ahead and check that A equals 1 to start. If not, then you're going to divide everything by A. And remember, this step 2 is because of that completing the square step, right? That completing the square step, it has to be equal to 1. So you might as well fix it now before you try to go any further. Step number 3 then is to go ahead and complete the square. So that's performing that setup, performing those steps in the setup. Once you complete the square, you're going to factor. And then finally, we're going to solve by our square root method. So we have one example that we'll walk through with this, and then I'll give you the 2 assignments, and then we can go over any questions from last night's. Can I erase? All right, so example number 1. X squared plus 10x minus 3 is equal to 0. Now, normally, I would try to factor this, right? So how could I try to factor this? AC method. So I would take 1 times negative 3, and then what's my silly question? Yeah, what multiplies to make negative 3, but if I added, I get 10. And your answer is?
Negative 5 times 2.
It's not negative 3. Right? I have to multiply to make negative 3 and add to make 10. So you gave me it backwards. Your answer to that, the question would be what? There's nothing. There's nothing that would do it. Okay? So if there's nothing that will do it, the philosophy of completing the square says that negative 3 is the problem. Right? That negative 3 is messing up my whole problem. So I'm going to get rid of it. How do I get rid of a negative 3 there?
Add 3.
Yeah, what do I do to one side? I do the other side. So on the left-hand side, I'm left with I'm left with x squared plus 10x. And instead of leaving that alone, we're going to do a plus blank on that side. 0 plus 3 gives me 3, and I'm going to do a plus blank on this side. Because once I complete the square, I'm going to end up filling my blank on this side with it. But remember, it's an equation. What do I do one side? I have to do the other side. So I always put the blanks down. That way it reminds my brain not to neglect the right-hand side. That's the number 1 mistake, is to not mess with the right-hand side. Okay? All right, so now I'm moving on. A is equal to 1. So I'm good. Which means now I'm moving on to the completing the square step. How do I complete the square here? What am I going to do? Yeah.
Don't you take your b divided by 2 squared?
So 10 divided by 2. And then square it. So in the step below, we'll fill in the blank just so that you can see what we're doing here. So we got plus 25. But don't forget, what I did one side, I have to do the other side. You got to add the 25 to the right-hand side as well. Now, you forced this by doing this step to be a perfect square, which means you don't even need to bother trying to do AC method because you forced it. You can immediately go from this to x plus 5 squared. Where did I get that 5? That is the number before you square, every time. So you don't have to bother trying to do front times the back, answer the silly question. If you did these 2 steps, it will be that every time. Okay, so remember, pull that number down as your square. On the right-hand side, I got 3 plus 25. That gives me what?
28.
This is a setup like what you've been dealing with for the past couple days. How do I solve this?
Square root it.
Yeah, I have a perfect square here. So to get rid of the square, we're going to square root both sides. The moment you throw down a square root, what do you have to do? Plus or minus. All right, so square rooting a square leaves me just x plus 5 equals, what do I have to do with the 28? Well, it's not a perfect square. Yeah, I have to do my factors. What multiplies to make 28? 4.
2.
All right, so now what?
You have 7, 3,
I have what?
7, 3.
I got 7 times 2 times 2.
So So it's.
Did you take the pair out?
Yeah, so I got pair of twos.
So we have 2 square root of 7.
There we go.
But
Yeah.
I even like, it's set down here.
But the 7 doesn't have a pair, so the 7 stays inside. The pair comes outside. All right, are we good? Am I done?
Mm-hmm.
No, what do I have to do now?
Subtract
Subtract the 5. And then how am I going to write my answer then?
X equals -5 and plus or minus 2 squares.
How many answers are being shown here? 2. One with the plus, one with the minus. Okay, so don't forget that. You still have 2 answers here, even though it's kind of chunky. And then that would be my answer. I can't add the 5 and 2 together. Why not?
Because you don't know if 2 is.
Yeah, the 2 has a square root 7, right? So I can't do that until I figure out what the square root of 7 is. Does that make sense? All right, take out the assignment that I gave you yesterday. Our homework's going to be kind of weird because we decided to do the 2 days in one. In that when you work this on your assignment, you're going to kind of go out of order a little bit because you're going to match what my board is saying. Okay? So if you turn to the